This video will look at the least squares regression line on an 84 CE. I'm first going to play a small video within the video.
This video will focus on linear regression. Linear regression finds the linear equation that best fits a data set. One common method is called the least squares regression line, or LSRL. This method looks at the sum of the squared distances between each data point and the line. In this graph, I have data points and a line, and notice all these dotted lines, those represent the distances between the points, between each point and the line. If I square each of those distances and add that all together, the least squares regression line is the line which makes this sum as small as possible. We will use technology to find the least squares regression line. So let's look at an example. The data we're going to look at is mass that's put on a spring and the length at which the spring becomes. Here's our data points. You might want to go ahead and try to work this with me. So go ahead and put your data into your calculator.
So here's our calculator. We want to put our data into it. Let me just quickly show you, if you want to clear a list instead of doing delete, 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 if you go ahead and highlight the very top of the list up here where it says L1 and now press clear and enter, it will go ahead and clear the entire list for you. Now go ahead and put in your data. So here's our data in L1 and L2. You might want to look at the data, right? So you can go to second stat plot. I need to actually turn this on and remember that we want to choose a scatter plot. And our data is in L1 and L2. Usually that's the default, but obviously I've been playing around with some other things on here. And then you can either press, obviously if I press graph, I've got an equation there, I'm not seeing my data, but remember to always use that zoom stat, which is zoom 9, and it'll focus in on whatever your data values are that you're trying to plot. So here's our data. Now we want to come up with a line that best fits that data, right? Is it here? Is it more flat, right? What's going to be our least squares regression line? So you want to go to the stat button, and then you're going to actually arrow over to calculate. And number 4, here are all your different types of regression. Notice number 4 is linreg and number 8. Those are both linear regression. Just notice that A is your slope in this case, and your B is your slope in this case. The reason these were put in, one was, I think the number 4 is a mathematician, and number 8 is more for a science way of looking at it. But we're going to look at number 4. You can choose number 8. I'm just going to press 4. You could also arrow down to 4. Now it is asking us where our data is. We put it in the default. It's in L1 and in L2. If it were in the other lists, you would have to put those in there or put the names in there. Now, mine actually has something in the frequency, which you don't want to have anything in there. So go ahead and delete that out of there. And if you go all the way down to calculate and press enter, you get y equals A is your slope and B is your y-intercept. Notice on this one, there's nothing else on here. Usually it should give you your R value or your correlation value. If this is the first time you've ever done that, you might have to turn something called your diagnostics on. And to do that, if you go to second 0 for the catalog, arrow down or go ahead and press D, and you're looking for where it says diagnostics on. I probably should have just pressed D, or there we go, diagnostics off. I'm going to go ahead and turn them on. Press enter. And then press enter again till it says done. Now you shouldn't have to do this unless your battery completely dies. So now if we go back and we'll practice our steps again, go to stat, arrow over to calculate. I'm going to press number 4 this time. My data is all in the right places. And now when I do calculate, notice now besides the slope and the y-intercept, right, that's our least squares regression line. we're getting an R squared and an R value. R is your correlation. A 0.9919 means that our data is very strongly, positively correlated to a linear. Again, remember, R defines how well it represents a linear equation. And the R squared, that is your coefficient of determination, and that tells you what percent of the Y values can be predicted using this least squared regression line on your X values. So we know it's going to fit well. Let's go ahead and see it. Now I could write down all the values, right? I could write down Y equals 0.04, X plus 18.12 and put it into my Y equals. But what you can also do is, let's go back to stats, practice again, over to our calculator, down to number 4, and there's our X, there's our Y. Notice the fourth line down says store regression equation. And here's where you can store it in one of those, right, Y equals equations, Y1, Y2, and so forth. So let me, go back to our linreg, and down here you want to put in, let's put it in the first Y1, but you can't just type in alpha, Y, and 1. You actually need to go to this very important, right here underneath the red arrow down is this VARS, which stands for variables. If you press that, we want a Y variable. So we're going to arrow over to Y. We're dealing with functions. Press enter, and there's where all your Y1, 2, 3, 4, and so forth are. So I'm going to go ahead and select Y1. Now everything looks the same, and even if I go down to calculate, right, it looks exactly the same. But the nice secret part is if I go to my Y equals now, bam, there's the equation with all the decimal values in it. And now if we go to our graph, and again, I should just be able to press graph because I already had it zoomed to the correct dimensions. There's our data, and there is our linear regression equation. And now with that line in there, we can find any value as well using our calculator. Remember, if you go to second calculate, and I just choose a value, let's say I wanted to find how long the spring will stretch if we put in a mass of 75. So if I just type in a 75 and press enter, there is our length of our spring, 21.14 centimeters. And that is how you use a 84 CE to find linear regression.